Okay guys, here is another video. I hope this helps. We're going to be doing today talking about Chapter 9.3. Before we do that, let's talk about what we learned in the last unit. In Chapter 9.2 we learned that this is an expression, and if I wanted to be able to factor this, I had to take out the greatest common factor and put it outside the parentheses. And the reason why we did something like that was because if you get a quadratic, and remember a quadratic is an expression that's going to have an x squared term. So if I wanted to solve for x, I can't do what I learned in the first part of algebra because you have a quadratic. So because it equals 0, I'm going to factor this side, and the greatest common factor here would be 3x because they each have a 3x. And then when I divide 3x, to get rid of it, I'm left with 2x plus 1. And now that I've factored that side, and now that you have a multiplication problem that equals 0, I can set each equal to 0 and solve. So one of the answers could be -1/2, and the other answer could be if I divide both sides by 3x equals 0. Well, now we're going to give you another, in Chapter 9.3, we're giving you quadratics. This right here, that's a quadratic expression because you can notice one of the terms is x squared. But if I ask you to factor that, it's tough because what's the greatest common factor of these three terms? Well, there's not one thing. I mean, this one has an x and this one has an x, but this one doesn't. So you can't really take out a greatest common factor. So you would think that you wouldn't be able to factor this, but you can. Basically, this was the problem from the previous slide. When you have a trinomial, and you can see this is a trinomial because it has 1, 2, 3 terms, and it's in a specific form. Now the form looks like this, and this may be confusing because this for some of you the first time you're seeing something like this. But all this means is that it's a fancy way of saying that your trinomial looks exactly like this, but with a, b, and c being numbers. So if you think about this, -6 would be my c, my -5x, -5 would be my b, because it's the number in front of the x, and then I have an a, x squared. It just so happens that there is no number in front of the x squared, so we have to assume it's 1. But you can see that this particular expression is in this form. You just are substituting a, b, and c with numbers. Now, here's a trinomial, but this trinomial is not in this form. So we're not talking about trinomials that look like that, because in this one, first of all, you have x to the third power, and then you have another variable, y. So this one definitely does not look like this one. And then you have, here's another trinomial. Now, this is a trinomial, and this trinomial looks very much like this one. So it is in this form. But in Chapter 9.3, I'm going to show you how to factor very specific trinomials that look like this. But in these problems, the a will always be 1, which means you will not see a number in front of the x squared. Well, in this problem, even though it's in this form, the a happens to be 5. So we're not talking about trinomials like this today. So trinomials that are in this form would be things like x squared minus 6x plus 9. X squared plus 7x minus 10. X squared plus 10x. I mean, you're starting to see the hint. And it doesn't have to be x. It could be like the letter a. A squared, as long as there's another a. Plus a, because the number in front of a is a 1. Minus 9. These are all the types of trinomials that we're talking about in Chapter 9.3. So how do you factor a trinomial that looks just like the trinomials we're talking about? So I'm going to give you 2 examples, and I'm going to bring over the example from the last one. And just make sure I wrote it right. Alright, so these are 2 trinomials, and I can see that they're in the form of x squared, because a happens to be a 1, and you'll notice that in each of these problems, there is no number in front of the x squared, so we assume that it's a 1. And then there's plus or minus some number in front of an x. Well, here you have a -5. here you have a negative 10. So far so good. And the last number is either could be plus or minus a c, which is just a random number with no variable. Well, negative 6 and plus 200. So these are in the form that we're talking about. When you get a trinomial that is in this form, it's really, really easy. It always will factor into a binomial times another binomial. Whatever the variable is in the problem, that's what's written first, x and x. Because that's how you get x squared. So in this problem, how I would get x squared would be x and x. Now to find out what the other numbers are, you take the last number, which is this, which we call c, because remember, that's the c, and you're looking for the factors of c. Let me do an easier one first. This one on the right is a little easier. So I'm going to go negative 6. What are the factors of negative 6? Well, let's think about these. Factors of negative 6. You got negative 3 and 2. You also could do 2 and negative 3. Negative 6 times 1. And 6 times negative 1. And I believe those are all the factors of negative 6. So we found the factors of this one. But not only do they have to be a factor of negative 6, they have to add. The two factors have to add to whatever the b is. So we're looking for two of the factors that when you add them together, you end up with a negative 5. Well, this one gets you negative 1, so this can't be it. These factors get you positive 1. Well, that's not it either. But negative 6 plus 5, this is what gets you negative 5. So you put those two factors, minus 6 plus 1. And this is the factored form of this original expression. And if you don't believe me, you can do FOIL, and you will end up with, I promise you, the original expression. Again, you're looking for the things that multiply to the last term that add to the middle term. So now let's try another one. Now, right here again, I see that they're in a specific form, so I'm going to go ahead and erase the other side so we have a little more room. And by the way, if you think you got the idea of this, you might even want to pause the video and do the next one and then check it with what I'm doing. So here's how you do it. You're looking for, again, because it's x squared, bx, and a c, that specific trinomial, and the number in front of the x squared is a 1, I know it's going to be x and x. You don't have to worry about it. Now we're just looking for our other two numbers. So we're looking for our factors of 200. So right away I know that, oh, and here's the other thing. If it's a positive 200, but look, I'm looking for things that add to negative 10. Well, if I put two positive numbers like 20 times 10, there's no way that you can add, those are factors of 200, but there's no way that you can add those to get a negative number. So that tells me that my two factors are going to be negative, because a negative times a negative gets me a positive, but a negative plus a negative will get me a negative answer here. So, for instance, two of the factors could be negative 20 and negative 10. But when you add those, you don't end up with the original problem. Oh, and you know what? I think I actually, for this problem, so you know that these add to negative 30, so that won't work. And then you also have things like negative 50 times 4. Okay, that doesn't work because that adds to negative 54. And you're thinking about a bunch of different of these factors. I mean, there's a lot you can do. Negative 25 and, let's see, negative 25 and 8. Or and negative 8. Or you switch those around, they're the same thing. But you don't get negative 10 there. You get negative 33. So we think of all these random problems, and sometimes we're not sure if we actually got all the factors, because these right here might not be all the factors. So one way that you can make sure that you have all the factors is to take the number 200 and do the prime factorization of 200. 10 and 20, 5 and 4, 2 and 2. 10 breaks down to 5 and 2. So the prime factorization of 200 is 2 times 2 times 2 times 5 times 5. Well, just to make sure that we did that right. These should add to 200, which they do. So I did this because if I take different combinations of those numbers, I can get all the factors. For instance, if I take 5 times 2 times 2, you get 5 times 4, so you get 20. And then if I take the missing ones, 20 times 5 times 2 is 10. That's a factor. We already had that one. Then I could take, instead of that, I can take, let's maybe take 2 times 5 times 5. So you get 2 times 5 times 5 is 50. And then what didn't you use was the 2 times 2. So 50 times 4 is another factor. Well, we already have that. 200 times 1 would be another one. But remember that we're making them negative 200 times negative 1. Well, after you go through these, if there's nothing that then gets you negative 10, you could just say that this is not factorable. Because there was nothing that multiplied to positive 200 but then added to negative 10. Here's an example of how this might show up in a word problem. John's height after diving off of a diving board can be found by the function x squared minus x minus 20. By the way, quadratics form parabolas. And that's why things like diving or jumping up in the air or rocket launches will always kind of form this path. They don't form straight lines when you dive. You kind of go up and then you come down. So how long does it take him to hit the water? Well, here's the function that we're going to use to find out two things. We're comparing time, which is x, and f of x, which is the height that John is at any given time. Because depending on where you are in the problem, you could be many different places, many different heights. Well, I'm going to take this original problem right here, and I'm going to ask myself, what information, in order to find out what x is the time, and the problem's asking us at what time does it hit the water? Well, it must be giving us the height. So I have to think to myself, what's the person's height? Where is this person when they hit the water? And if you think about it, when the person hits the water, their height is equal to 0 because they're not up in the air. They're just right at the water. So I can set this equal to 0. Well, now all I have to do is solve for x. Well, what you're going to notice is you have a quadratic. And there is no greatest common factor, but in order to solve for x, we're going to have to factor. So I notice that it's in this form, x squared plus bx plus c, even though you could have minuses, remember. So I remember that for this type of problem, I can factor into two binomials. The x squared gets broken into x, and then to find my other two numbers, I need to say, what are the two things that multiply to negative 20, but add to negative 1? So I think of all the things of how I get negative 20, like negative 20 and 1. Well, that doesn't get you negative 1. But how about positive 5 and negative 4? Well, those are factors of negative 20, but those do not add. When you add 5 plus negative 4, you do not get negative 1, you get positive 1. So negative 5 times positive 4 are factors of negative 20. They multiply to get you negative 20. But if you add these two numbers, you end up with negative 1. So those are the numbers I'm going to use. Negative 5, positive 4. And if you did FOIL, you would 100% end up at that expression. But I wanted to factor it because it's set equal to 0. And now that it's set equal to 0, I can do what I did in the last chapter. Set each one equal to 0. Solve both of them, and I get an answer of 5. So at 5 seconds and negative 4 seconds. Well, the negative 4 seconds don't make sense. So we know that as John jumps off the diving board, right over here, after 5 seconds, that's where he's going to hit the water. And that's your answer to the problem. I could cross that one off. Here's a last example. How do I solve for x? Well, again, you're going to notice that you have a quadratic and you have an equal sign, so you're going to be able to solve this. But the only way to solve quadratics, or for now the only way to solve quadratics, is you have to factor. But the reason you factor is you have to set it equal to 0. Well, this isn't set equal to 0. So, but it's really easy to just move this negative 16 over by adding 16 to both sides. Now I have a quadratic that equals 0. And I'm just going to say 2x squared plus 12x plus 16 equals 0. Well, I'm showing you this problem because right now you don't know how to factor this problem because there's a 2 in front of the x squared. Well, that's not, we need a 1. But whenever you get a quadratic equation, you always, even if it's a trinomial, you always want to ask yourself, is there a GCF that I can take out? Or, because it's an equation, you don't even need to take out the GCF. Is there a number that I could divide every single term in here to reduce this? And there is, because you have a 2, you have a 12, and you have a 16, and you could really divide anything by 0. You're going to still end up with 0. They're all even numbers, so I can actually go ahead and divide everything by 2. And if I do that, I get x squared plus 6x plus 8 equals 0. Well, now you have a problem like we were talking about. I can factor this because it's that special trinomial. So I have x and x, and I need to find the rest of my numbers, which equals 0. So I'm looking for my factors of 8, but that add to positive 6. Well, I can think of that. Positive 4 and positive 2. Well, now that I've factored this expression, or it's an equation, I can, because you have this times this equals 0, I can set each equal to 0. And then I can solve. And that's how you would get your 2 answers. There's one thing that I do want to talk to you about, is that there's a difference in that, just going back to that last problem, 2x squared plus 12x plus 16. If this was not an equation, you can't divide, because the only time you can divide to, make the number smaller is if there's an equal sign and there's a number on the other side. So if the directions were just simply to factor this, you couldn't divide by 2. You would have to factor a 2 out and just leave it on the outside, like so. In the last problem, we didn't even worry about keeping that 2 on the outside because because it was an equation, we could just divide everything by 2. But when you're factoring, you have to actually take out the greatest common factor and show it. Then you can take this part and factor this further into what we got in that last problem, which was x plus 4 times x plus 2. And notice I'm not going to find out what x is because this is not an equation. It's just an expression. But notice the 2 has to stay on the outside.